So in today's topic, let us try to understand what is a service and what is the benefit of using the service and what are the types of services that we have that we can create in our Kubernetes cluster. Okay, so services we have a totally of types like 6 actually. ClusterIP, NodePort, LoadBalancer, ExternalIP, ExternalName, and then we have this one, Headless service. Okay, so these are the types what we have, but generally speaking in services most of the cases we go for a default one until unless there is a really a need. Either we go for cluster IP or we will go for headless service. Okay, headless service is for stateful set applications. Okay, so what is a service actually? Okay, let us forget about the types. First of all, let us understand what is the service, what is the benefit that I get when I try to create a service for my application. So in general, till now we have created replicas of our pod either through replica set or replication controller or daemon set, not a daemon set, daemon set also, and the deployment. Okay, so daemon set in the sense your application is running on multiple nodes, right? So that's the reason. Okay, now let's say you are running so many replicas in the background. So how will you communicate to a application? Which pod you will try to communicate? Is it the first replica, second replica, or a third replica? So we cannot change it, right? So let's say there is a front-end application. Now you deployed a back-end application in the Kubernetes cluster. Okay, and front-end application also you are trying to deploy on the Kubernetes cluster itself. Now that particular front-end application wants to communicate to the back-end application which is running inside the pod. Okay, now which IP address you will update in the front-end application? Means somewhere you will update in the configuration file, right? So for the front-end application you will tell that try to go and contact to that particular pod or particular application. So how will you reach there? Which pod IP address you will give? Okay, you have given the first pod IP address for time being. Okay, if this pod is down or something went wrong, what will happen? This pod IP address will get changed. It is never constant. It is ephemeral IP. Okay, and you cannot bind your front-end application to a specific pod, right? We have multiple replicas running. What is the benefit of using replica? Even if one pod is not available, there are other pods running in the background with the same application and data to accept the request. So in for this particular high availability we need to use a load balancer. Okay, so to have a load balancer, what is the purpose of a load balancer? So you will be trying to reach to the load balancer whether it is IP or whether it is a DNS name, later thing, but you will try to reach to the service, and that particular load balancer will try to divert the traffic to each and every pod using a round robin fashion by default. Okay, round robin fashion in the sense first request will go to the first one, second request will go to second, third request will go to third, fourth request again will come to the first one, fifth, sixth, 7, 8, 9, like that. So it is called as round robin fashion. Okay, so by default cluster service will try to use a round robin algorithm to divert the traffic in the backend. So that's the reason service is called as Kubernetes internal load balancer. Okay, it is internal load balancer. Why it is called internal load balancer and all we can discuss. Why? Because your cluster IP is a private IP address. You cannot access outside the cluster. Okay, and one more thing, every service whatever the type you use you will get a DNS name. Okay, every service will have a DNS name. Why a DNS name was given to the service? Because you cannot rely on IP address. Why? Because this IP address may not be constant. Tomorrow if I recreate this particular service, let's say I deleted and I recreated. So if I recreated it, the IP address will change but the name of the DNS will never change. Okay, until unless you will change the name of the service or location of the namespace. Okay, today if you deployed in this particular namespace, tomorrow if you deployed in another namespace, yes, the name will change. And if you try to modify your service name, yes, the DNS name also will change. If you try to recreate the same service multiple times, IP address will change but DNS name will never change. So that is a benefit we get from the service DNS name. Who will assign this DNS name? If you try to recall in the previous sessions what we have discussed, actually in the starting sessions actually. So when you execute kubectl get pods hyphen n cube hyphen system namespace. So if you execute this particular command, you can see a component which is running in your Kubernetes cluster, that is nothing but core DNS. Okay, so this core DNS will try to ensure that, so it is running on two nodes actually, or maybe two replicas. You can see one is running on control plane and one is running on compute plane. Okay, so what this particular core DNS will do, it will try to assign the DNS name for your services. Okay, so that's how it will try to assign services and the pods. Okay, so the DNS name will be assigned to your services. How it will be assigned, what will be the naming convention, let us see. Let us say you have created a service called, for example, nginx hyphen svc, or let's say nginx hyphen service. Okay, that is a name of your service. Okay, now what will be the DNS name? Okay, so Kubernetes will try to assign a DNS name for this particular service as name of the service, service name, okay, dot in each namespace. Okay, namespace it is created. Okay, then dot default dot svc dot cluster dot local. Okay, so how I will come to know that this is constant? This suffix, okay, this suffix is constant. This will never change. Okay, why and all I will tell you. Okay, this will never change. But only things which will change for service to service is nothing but what is the service name and on which namespace. Why on which namespace? Because the same service can be created in multiple namespaces. Okay, that is clear, right? Same service you can create in multiple namespaces. So when you try to create in multiple namespaces same service, then you have to pick a specific service, right, which you want to reach. Okay, so that's the reason we have to give the service and the name of the namespace, and then this is common default.svc.cluster.local. Okay, so this will be your DNS name. Okay, so let us try to create some sample example and let's say how to create it. And one more point, which is nothing but, if you see, by default we have different types of services as I told you, like ClusterIP, LoadBalancer, NodePort, ExternalIP, ExternalName, and then we have Headless service. Okay, so here by default when you try to create a service without specifying any type, by default it will pick ClusterIP. So ClusterIP in the sense the application will be reachable only through this particular IP address of the service, okay, or the DNS name, that's it, and it is within the cluster itself, internally within the cluster. Okay, you cannot access your application or you cannot send a traffic to that particular service from outside the cluster. Okay, if you want to access your cluster from outside, okay, you need to expose or you need to create your service through NodePort load balancer. Okay, so what is NodePort? NodePort in the sense when you try to create your service with the NodePort, that particular port number will be opened on each and every node. How many nodes you have in the cluster? On every node it will open the port number, and when a person tries to use a node IP address and this particular port number, it will redirect the traffic to the ports using a load balancing. Okay, so this node port will try to do that. Okay, when you try to use a node port type service, which port number will be opened on the node? It will open from 30,000 to 32,650, maybe 27, like that. Okay, totally around 2,000 port numbers, 2,500 port numbers. Okay, by default it is. If you want to use a specific port number, we have to customize the configuration file. Okay, but by default if you don't specify anything, NodePort will try to pick the port number from 30,000 to 32,567 port number in between them actually. Okay, any port number it will pick randomly and it will allocate to that particular application, that particular service actually. So here the kube proxy will come into picture wherever it is. Okay, So kube proxy will try to take the request, and whatever the request is coming to that particular node with that particular port number, it will check the IP tables, and then through the IP tables it will transfer the traffic to the pods using a round robin fashion. Okay, so that's how it happens with the node port. Okay, so then there is another type called load balancer. So why we can go for load balancer? Because in the node port I can see a disadvantage that unnecessarily I'm opening the port numbers on all the nodes, though it is not really needed. Okay, so opening the port numbers on each and every node, it's not realistic. Why? Because I need to work on the firewall as an administrator. I need to open this particular port number. You never know what port number your node port will try to open. Okay, if it is a fixed one which you will specify in the YAML file, that's fine. Okay, anywhere between 30,000 to 32,000. If you try to pick one particular port number, always you will try to use the same port number for that particular service, then fine. Always I can update the firewall with the fixed that particular port number to be allowed. But if it is a dynamic, then it is not that easy for us to open the port number. I need to open all the 2567 port numbers in the firewall on each and every node. So unnecessarily you are opening to your vulnerabilities, right? So that is not a feasible solution in the productions to access your applications through a service node port. Okay. Then there is another alternative called load balancer. So load balancer, in the sense, it will create a load balancer IP address or the DNS if you are using a cloud. If you are using on premises, we can use a IP address. So one IP address will be used for each and every service. Okay, or that particular service will create a load balancer. That IP address can be used for that particular service. Sorry, that particular pod. Okay, so either you can use an external load balancer, or internally you can deploy. You have to deploy a load balancer if you are using on premises setup. Now this is my on premises setup, right? I'm not using any cloud. So there is no internal or available service load balancer. I have to deploy. I have to deploy, then my service can use that particular component to create a load balancer functionality. If you are using cloud, what will happen? Let's say if you are using Azure or AWS or Google Cloud, your cluster will be created through AKS, GKS or EKS service. Okay, then what will happen? Every cloud has its own internal service called load balancer service. If it is AWS, we have application load balancer, network load balancer, gateway load balancer, and elastic load balancer. Azure also we have a load balancer. GCP also has a load balancer. So your Kubernetes cluster will contact to that particular load balancer service. It will try to create an IP address or load balancer DNS, and that will be assigned to your service. So people can try to use that particular load balancer public IP address or the DNS name to reach to your application. Okay, that's a benefit we get from the load balancer. Okay, the only disadvantage is, like, it is you have to pay for what you are using for the traffic and the IP address which you have created for that particular application. Okay, so you have to be careful which one to be used and which one should not be exposed. Based on that, you can reduce the cost effect on this particular type service. Okay, nothing else. Okay, then we have external IP, external name, and headless service. Headless service I will be discussing in the stateful set application. What is that exactly? What is the intention of using headless service, especially for stateful set applications? Then we have external IP, external name. So external IP name we will be discussing once the practical session was done on this one. So I'll be creating another session. So on another session we will be discussing about that rest of the topics, okay, of a service types. So let us jump into the practical session, how to use a service type called ClusterIP for your backend application load balancing. Okay, so
Hello.
so here let us try to create a service. So in order to create a service, we have a service floodler. You can take a basic example of a service. Okay, so here this is the service. Either you can use a pod, or you can use a deployment, or you can use replica set or replication controller. Okay, or a daemon set. Okay, whichever you use, it's up to you. It's your requirement. Okay, so in this example, let me try to use a deployment with the service front end service called ClusterIP. Okay, so let me take this example by default. So let me go to the bottom, copy. Let's go to our terminal and let me try to create a directory called mkdir services. Okay, services, and then say like cluster IP hyphen nginx. Okay, dot YAML. Let me copy paste here. Yeah. So let's try to understand what we are trying to do in this YAML. In this YAML, we are trying to create two objects. One is service and one is deployment. Service you can see here. Before that, let me try to explain about deployment. So deployment, this example we have seen so many times. Let me repeat once again. This is the deployment, and here we are trying to create three replicas, and this is the label which we have assigned. In this, we are trying to create two containers. One container will try to write some data into the index.html, which will be stored in the shared storage like volume called empty.dir, and that particular index.html file will be used by your Nginx web application. Okay, so that is so simple. It's like a sidecar container. Okay, where one container is concentrating on writing the data. For every 10 seconds, it will update some data into the index.html. That same index.html is mounted to your volume, and the same volume was used by your Nginx web application as well. So obviously whatever the data was written by your container will be used by your Nginx container. Okay, so this is called as sidecar container approach. Okay, so for this particular replicas to be accessible through the load balancer, I'm using a service, internal load balancer service. Okay, and this is the name. Here the selector is important for us. Selector in the sense to identify your pods, to be added in the backend load balancing. So we are using selector. So what is the benefit we get by adding like this is in the sense, tomorrow if the pod is deleted and the new pod was recreated, automatically service will come to know it. Okay, because it will identify your pod based on labels, not with the name or not with the IP address. Okay, so that's the reason even though the pod was recreated, your Kubernetes will come to know it, service will come to know it, and it will automatically assign that particular pod as a backend component to load balance the traffic. Okay, so that is called as endpoint. Okay, so now these pods are called as endpoints for this particular service. Okay, so now actually this particular service will create another object which is called as endpoint. In that endpoint you can see what are the pods it has. Okay, so we will see that as well. So this is the service. So the service will accept the request on the port number called 80. So service will accept the request on a port number called 80, and it will redirect the traffic to the port number where your containers are listening on 80 port number. So don't try to modify the target port number on your own. It depends upon your backend application. Okay, backend pod, whatever it is listening, your actual application which you are trying to send a traffic, that particular port number you have to specify in the target port. This port, it is up to you. You can modify whatever the port you want, you can just specify. Okay, let's say I want to make it as, instead of 80, since everybody know it, I will modify it to 8080. Okay, let's see the scenario, right? So here 8080 port number, in the sense your service will listen on 8080 port number, the IP address or the DNS, and that particular port number will redirect the traffic to the backend pods application which are listening on 80 port number. Okay, so let's try to save this. I have not specified any type, so let's say what will be the default type of service that will be assigned. Okay, so I don't have any applications running, just to show that. Okay, only one service was there, that is by default you will have in Kubernetes. Okay, and yeah, so let me try to create this. So kubectl create -f service and this. So it has to create a deployment object as well as service object. Okay, so kubectl get all -o wide to see the IP addresses. Okay, now you can see they are under creation process. You can see your service by default was created with ClusterIP, and this is the IP address. Okay, and this is the port number where your service is listening, and to the backend it will transfer the data. Okay, so let's wait until these are done. I think it doesn't take much time. Yeah, it's done. Okay, so now if I try to run a curl command, okay, on this particular service IP, if I try to run general, it doesn't work. Why? Because it's not 80 port number, it is 8080 port number, right? 8080 actually. So you already know that this particular cluster is having some problem, network issues in my, it is having some delay. You can see now you're getting a response. Cluster IP you can access from anywhere. Okay, no need to worry whether it is running on here or here. See, this IP address is a virtual interface, virtual IP address. Okay, it is not a physical Ethernet card where you get an IP address. It's a software created interface. For that interface it will have an IP address. Okay, so that's the reason those are called as virtual IP addresses. Okay, so this IP address you can access from here or any node in the cluster. Okay, so if you execute the command you are getting a response. You don't know from which pod it is actually, because every pod has the same data. Every pod has the same data. Okay, so for every 10 seconds it will generate some random data. So that's how it is shared among all the pods, and this pod is used as a front-end load balancer using a service called type ClusterIP. Okay, so this is how you get. So now what is a DNS name? So now you can see you can access. See, there is some delay which I've already told you, right? Now it was working. Okay, that's okay. Now what I want to do is nothing but I want to show the DNS name. So now on an assumption, what should be your DNS name now? My hyphen service dot default. Why? Because it is created in default namespace. Default dot svc dot cluster dot local. Is that true or not? Let me try to execute. So generally what people will try to do a mistake is nothing but they will try to execute ns lookup command. Ns lookup command is to fetch the name servers of your domain. Okay, so now if I try to execute, or we can get the a record for the DNS name as well. So now if I try to execute some IP address, let's say 10.96.190.70. Okay, you are not getting any response. See, these DNS records can be identified only by your applications, not from your nodes or outside of your cluster. Even from the nodes, you cannot reach to that particular DNS names. It is not possible. See, curl my hyphen service, if you execute, it doesn't work. It doesn't make any sense. It doesn't know where is this DNS is resolved to. Okay, if you have created some particular pod, temporary pod or any pod, and from inside that particular pod if you try to execute ns lookup or any curl command, then it will try to reach to the DNS name. Okay, so your Kubernetes components or the applications will come to know the DNS but not from your nodes. Okay, so you have to understand about this. The DNS name of the service will be reachable only within the pods. Okay, from applications to applications, not from the node to the application. Okay, so just remember that particular point. I've already proven this. Let me try to create a temporary pod and let me try to show how we can utilize that. Okay, so to create a temporary pod we can use kubectl command run. Okay, hyphen di hyphen rm. Temporary means once the commands has been executed I need to remove this particular pod. So for that you can give hyphen rm. Okay, hyphen image, image equal to, I have one more of my image where all the packages are installed which are needed to run ns lookup, ip command, ping command. If I want to run, all the packages are installed in this particular image. You can also use it, actually it is a public image. Then yeah, hyphen bash. I just want to log into the shell of this particular pod. Once I logged in, I will run the ns lookup command. Utils. I have this image actually. Let me try to search for that. I have in my Docker hub. Let me see if I can get it. You can see here utils, yeah, here it is. Okay, if you go there, almost it is 166 download, latest only, that's fine. Okay, so there are no tags. Latest is an automatic tag. Okay, you can see you logged in. Yeah, it took some time to download the image, that's okay. So now you are inside the container. So now I can execute IP space a command. I think this is not installed. Okay, so DNS ns lookup and give your IP address of your cluster IP address. Okay, now you can see you will get the DNS response. Let's wait. Here there is a problem with networking. Okay, so don't worry too much about it. You can see now. Do you got a response of your DNS name? My-service dot default dot svc dot cluster dot local. Is that true? What I've told? Okay. So what are the DNS name I have told? svc.cluster.local. Maybe I have told like kubernetes.svc.cluster.local. Yeah, it's a svc.cluster.local. Now this is my DNS. Okay. Now if I try to run curl command, I think curl is installed. Yeah. So curl on this particular DNS name, see, I will get a response from the pod. Let's wait. So I have run dig command. Okay, instead of ns lookup. Now you could see I have run the dig command. Here you can see the response which I got. Okay, dig, give the domain name. When I give a fully qualified domain name, you can see you got your actual IP address of this particular service. Okay, so this is how. So this is adding a record. You can see this is called as a record. If you know much about DNS, if you want to add for your domain to reach to your website where your application is running, then you will add a record. First DNS name server, that's fine. That will be taken care where you have hosted your website. Okay, so that will automatically add a name servers. Now apart from that, where your actual web application is running, that particular web application public IP address, you need to add it to that particular domain name. So where you will add it, you will add in the DNS records. That is called as DNS record, a record. So automatically my DNS has added a record for this particular domain to this particular IP address. So that's the reason I will be able to reach to this particular domain as well. Okay. So the mistake what I have done when I run the curl command is simple. No one said me actually. Okay. What is the port number I have used for the service? It's not 80, right? It's 8080. Okay, so then I'm getting a response. So it's mistake from the port number what we have given. We customized it, right? For a service we have told that it should listen on 8080 port number, not on 80 port number. So that's the reason you are not getting response in the earlier command what I have executed. Okay, so then first I executed dig command. I was able to get the reverse lookup zone of this, sorry, forward lookup zone and the reverse lookup zone response of this particular DNS name and IP address. Okay, so this is how from your inside the pod you can reach to that particular other applications using the DNS names. So the component to component will communicate with each other on the DNS name. But from the node, you cannot reach to that particular application on a DNS name because that is only for internal Kubernetes DNS configuration. It's not from your node or from the external. Okay. So that is one point which you have to really remember for this. Okay. So that is how it is. So our execution was done. So now what I can do is like I can exit from this particular pod. So if I exit from this particular pod, automatically it will remove the pod which it has created for a temporary purpose. Why? Because when I'm creating the pod, I gave -rm, which is nothing but whenever you exit from the pod, automatically remove the pod. That is the intention of using -rm. It is only temporary for my testing, right? So that's the reason. Okay. So this is how it is. So this is how the DNS names will be added to your services. Okay. Hope this point is clear. So this is about your cluster IP. Okay. So by default, when you try to create a service, the default service type is called as cluster IP. Okay. The cluster IP port you can customize whatever you want, but the actual target port should not be customized. It should depend upon what your pod is listening on. Okay. So here you can see your pod is listening on 80 port number. Okay, but your service is listening on 8080 port number. Okay, which is binded to that particular 80 port number in the backend. So when you try to create a service, I have told that in order to integrate that particular backend ports with that label, okay, to your front end service, it will use a component called endpoint. Okay, so kubectl get ep endpoint. You can see this is your endpoint service. For your service, that particular service will take this particular endpoint. So when you try to create a service, automatically this endpoint object also will get created. Okay, these two are interlinked. You can see your pod IP addresses here. That's how it is. You can see 118 117 116 116 117 118. Okay, let me try to delete one of the pod. Okay, so I will try to delete this particular pod 117. Okay, so kubectl delete. Okay, when this pod was deleted, Kubernetes will not try to, that service will not try to send a request to that particular pod. Why? Because it will run some health check. If your pod is not responding in the backend, it will not send a traffic to that particular pod until you get a response. Okay, so that's how it is. So I'm trying to delete this. See, a new pod will get created and you will see that IP address will automatically get added into this particular endpoints. Okay, let's see. Now we can say it got successfully deleted. So now what we can do, let's verify the EP. Now we can see something like 121. Okay, 121. It's not 117. Now I got 121. Okay, which means that the new pod IP address was automatically detected into this particular endpoint, and this endpoint will be used by your service to load balance the traffic which it is getting on the DNS name or the cluster IP address. This. Okay, so this is even though if you try to recreate the service name will be the same. My DNS, my hyphen service dot default dot svc dot cluster dot local. This will never change how many times you try to recreate. So that's the reason for the front end applications, the better way to reach to your application is to use a DNS name. Why? Because if you try to recreate the service, this IP address is ephemeral, it is not constant. Okay, so that's the reason even if you try to reach to the IP address, the problem is this IP address might change at any point of time if you recreate, unfortunately. Okay, that could happen right in the cluster. So the better way is to go with the DNS names. This will never change until unless you intentionally try to modify the service name. Okay, so if you intentionally modify the service name, yes, you have to update your front-end application. But if you have recreated the same service for multiple times, nothing to update you to your front-end application. Why? Because the name will be the same. Okay, and automatically your Kubernetes service is also able to use endpoint to identify your pods in the backend based on the labels. Okay, so whatever your service name, your endpoint name also will be the same. Okay, because these two are interlinked. Okay, yeah, so this is all. If why? Because how this particular endpoint is created, because in the service YAML file you have defined a section called selector. So whenever you define a this particular section selector, automatically endpoint will get created. If you don't define this, service will be created, cluster IP will be assigned, but there will be no endpoint created. Okay, let me do some particular testing. Okay, let me show you that how it looks. So copy this service no EP. Just I gave some name called no EP, means no endpoints. Okay, so that it is clear for me when I look at that particular file. Okay, so let me try to remove this. I will modify the name because I already have this particular service. So let's say Sudhir hyphen demo. Okay, same port like 8080 or 80, it's up to you. Nothing will happen. I have not defined any selector. Okay, forget about backend ports whether they are available or not. Okay, we are not cared about it. Create hyphen f service, it's created right now. So kubectl get svc hyphen o void. Now you can see your service was created. Okay, let us see the endpoints. So I should see some endpoint as well, right? EP shortcut name. Do you see any endpoints? No. Why? Because you have not defined a selector. When only you defined a selector, then only your endpoint can identify your ports, right? Based on the selector what you have written, the labels. So that's the reason the endpoint will never get created. Now if you don't want to delete the service, but you want to add your endpoints, then you have to write a separate YAML file, or through CLI you have to create an endpoint with that particular selector. So for that we have a documentation as well. You can just go for it. Okay, official documents. Okay, EP for Kubernetes. KTS. Where is that? Or maybe it is not able to identify EP in the sense. Okay, endpoint. Oh, this is some document. Okay, services, right? Just go for endpoint slice, which we also call it as. Let me go for the section called endpoint. Endpoint slices. Okay, you also have the topic. Let me try to show you one. Yeah, here it is. Now if I want to create it, see, for this service also I can use the same ports. How I can use it? Let me see. Your name of this particular endpoint should be the name of your service. That is the first point which you have to remember. Okay, that is the first thing you have to remember always. Because the service has no selector, the corresponding endpoints object has not created automatically. So you can manually map the service to the network address and the port numbers where it is running by adding the endpoint object manually. So now let's say if you want to add only the IP addresses which you want, you can add like this. Okay, simple. Let me try to do this. Now here the problem is, sorry, not the problem actually. Let me try to point. Okay. So now what I can do, let me try to delete this and add this one. Okay, here I will add the IP addresses. My service, I don't want to use this one. What is the service I give? Sudhir hyphen demo. But what IP addresses I want to update? The pod IP addresses. Okay, so let's see how to do it. There is a, yeah, 24 101 16 18 121. 16. I'm copying the same address. 16 18, right? 121 I'm not adding. Okay, that's it. So now just save this and create it, recreate. Okay, so replace, or let's try to do an apply and see whether this is allowed for us to add or not. Not all the options we can add. Okay, it's created. Okay, so now the endpoint was created successfully. I think we have not yet created. Okay, that's the reason. Yeah, so you can see here the service is already available. I have not disturbed anything. Okay, this is already available. Now you have created your endpoint manually. So now if you look at your endpoints, you can see the endpoint is available with only the two IP addresses what you have given. So now if I try to curl this with the port number 8080, you have to get response only from two ports. You don't know from which port you are getting a response, but you will get a response only from two ports. Why? Because as per your endpoints, you have written only two right now. There is no third port which is added. So this need to be maintained not by automatically, it is maintained manually, which is sometimes headache. Means like manually administration has to take care of this, but the problem with this is nothing but if the pod is recreated, the IP address will change. Let's try to do that. Will that get detected automatically or not? Let's see. We will try to delete the pod which is having a common IP address in the same both the endpoints 116. Okay, which is 116 here it is. So this pod, let us try to delete. We will see automatically this service will get detected. You already know about this my hyphen service. Let us see about Sudhir hyphen demo endpoint as well, whether that will get detected or not. Okay, so let's take this, kubectl delete this particular port. See, I'm showing you all the possible ways so that you don't get any questions here. Okay, most of the cases I'm trying to show you all the scenarios. Okay, this will be helpful when you're working on production. If someone asks you like why can't we do like this or this, what are the challenges we face, now you have some idea, you can give a justification to that particular scenario. Okay, why I can't go for this, why I can go for this, these are the drawbacks, these are the advantages. Always automatically detection is the best choice, right? Why? Because I no need to take care of this particular administrative part. Always we have to be in a position where administrator has to do a less work once a cluster is built. Okay, he has to simplify his job, not to make it complex. Okay, anyways, so now the new pod was created with the 122 IP address. Now if you look at your services and endpoints, you can see here it is still showing you the old IP address. It is not getting detected, it is maintained manually. This endpoint is maintained manually. Okay, let me try to delete this particular pod as well. Okay, so that this particular endpoint will have old IP addresses. So when I try to run a curl command, do I get a response or not? Let's see. So I will delete this particular pod as well. So kubectl delete this particular pod. Now your endpoint Sudhir hyphen demo is having old IP addresses. You don't have anything like 116 actually a pod, and you don't have anything like 118 as well. Oh, which one I deleted? 121. I could have deleted this one actually, 118, not this one. Anyways, that's okay. We can delete multiple times and automatically anyway, Kubernetes will try to recreate. Okay, let me try to delete that as well. So you can see now, anyway, it got changed 123, right? I want to delete 118 actually, which is common in both the endpoints. So this pod I want to delete to show that one will get detected automatically, one will not get detected. Why? Because one is created manually and one is automatic. Your my hyphen service is automatic detection, and your Sudhir hyphen demo is a manual detection. Okay. Okay. Now if you try to see your endpoints, 116, 118 are no, we don't have any pods. If you want the proof, let me execute this command and let me try to show your pods. You don't have anything like 118 and 116. You have 121, 122, 123, 124 IP addresses. Now if I try to run the curl on this, you see you are not getting any response. See this IP address, I am trying to reach to this particular service with this port number, I am not getting any response. Okay, but if I try to reach to this particular service, obviously I will get a response. Okay, okay, done. Okay, so this is how, these are the challenges which you might have when you are manually maintaining this particular endpoint. Always it is recommended, 99.99% is recommended to use automatic endpoints detection using a selector. So don't forget to create a selector when you are creating a service. If you create also, nothing will happen, but you have to maintain it manually. Even though if you recreate the service, nothing will happen to your front-end applications. Why? Because you are recreating with the same name, right? So that's all. For testing purposes, we can use this approach. Let's say I want to create a service, but I don't want to expose to the front end application. First, I want to do the load balancing testing and all. You can create manually your service without selector, then add your selector using endpoints, add it manually one pod and see how it is working, second pod and see how it is working, add the third pod into the YAML file of endpoint and see how it is working. In this way, you can do some testing. For that particular scenarios, it will work. This approach is fine. But for real-time applications which needs communication to the backend applications, automatic detection is really needed. Okay, to identify your backend ports which might change at any point of time, because the IP addresses are not constant, they are ephemeral. Okay, with this we have completed our service type called ClusterIP. So tomorrow we can see something related to NodePort, load balancer. For load balancer, I need to do some additional task. Why? Because internal load balancer, because it is on premises, right? In on premises, you don't have any service which will have a load balancer. You have to deploy it, and that should be running as a application. So we will see what kind of load balancer we are using for on premises, and then we will see what is the benefit we do get. Okay, so this is all about your Kubernetes cluster with a load balancer. Okay, load balance service we can discuss tomorrow, and today we discussed entire each and every topic related to service with a type called ClusterIP. Okay, thank you.